Hi, in this video I'm going to train Nuke's AI to isolate this dancer from the background and fully animate her motion using only about 20 still frames, while at the same time train multiple mats that we can use later on down the script. With Nuke13.2 we no longer have any limitations on the amount of channels you can train. This opens Nuke up to more complex training possibilities, as well as it means you no longer have to train similar networks over and over again. Like here, we would have to train the CopyCat multiple times, one for doing the animation of the dancer, or what we could call a style transfer, and then one for each mask that we want to create of the dancer. To get started, the first thing we need to do is go through our shot we'll be training on, and pick some keyframes where we think would help the CopyCat train the shot. For example, particular poses of the dancer, overlapping areas, like when she crosses over the tree, frames with lots of motion, or where there are light changes. We pull these frames out of the shot using multiple frame hold nodes and setting it to the frames we pick, which, as a new feature of Nuke 13.1, if you are on the frame you want to create a frame hold on, it will automatically set that frame hold to your current frame. We can then write out and read these frames back into our script and plug them into an append clip node to create a new sequence of just these frames, which we will use as the input to the CopyCat. The next thing to do is create the style transfer or your effect that you want to train and apply that on each of the frames we have chosen. For example, I want to create an animated version of this dancer, so I'm going to use constants and different rotor shapes to isolate parts of the dancer. The first constant to make is the one that we'll use as the background for our animated dancer. We then create a second constant. In this one, I pick the skin color of the dancer from the viewer by holding the control key and then left clicking on an area of the dancer that we want to sample. Then hitting O, we create a roto node and we can start making our roto shapes, making sure that we're still looking at that original frame in the viewer while we do this. First making that roto shape around the arms, then the legs, the neck and the head. Once I have the dancer's body roto done, I use a pre-mult node after the roto and then merge the now isolated body of the dancer over the black constant. We repeat this process for each part of the dancer, sampling and picking the color of the constants in the viewer for the hair and the dress, until we have recreated the dancer through our constants on that black background. This is repeated for each frame we have chosen from the sequence until we have the isolated dancer for each frame, and then again we use the append clip node to create a sequence of just our dancer. We now have our input and the RGB of our ground truth, which we will use to train our neural network. The next thing to do is create the different mats of the dancer that we want to train with alongside the RGB. For this, I'll create a second branch from my ground truth stream to create these on. First, to create an alpha mask of the whole dancer, we create a shuffle node and make sure that we are viewing the alpha channel in the viewer by hitting A while focused over it. Because we don't have any alpha, the viewer will go black. Using the shuffle node, if I take the red channel and drag its noodle into the alpha channel of the output layer, the viewer will now update to show that we have the red channel now also in our alpha channel. But since it's not a solid alpha of the dancer, we then create a grey node by hitting G in the node graph and we set its channels to alpha, as we only want to affect that one channel. Then, using the white and black point, we can make adjustments to the alpha, making sure that both the black and white clamp knobs are enabled so we don't have any values out of range in our mats. The next thing to do is create a new layer to hold this channel and then add that to our RGB branch of our node graph. So we create another shuffle node, but this time we use two inputs, one to the grade and one to the RGB stream. In the shuffle node, we need to change the second input from B to A, as we want to copy the alpha from one input to the other. We then pick the alpha or the RGB as the channels we want to shuffle on this input, and then looking at the B input's output layer in its properties, we can pick a layer from the drop down menu to shuffle or copy our channels to. For example, we could use the mask layer as the output layer we want to shuffle to, and then by taking the RGBA alpha from the A inputs channels, we can drag this into the B output mask layer. Now looking in the viewer, we have a new mask layer available to select, which now has the alpha of the dancer on it. So we now have a new layer with this new channel available. We need to repeat this process for the other parts of the dancer we want to isolate. So for example, the body, the hair and the dress. And when creating new layers for each mat, for example, we now have the hair isolated in the shuffle node's output layer. Instead of picking from the list of available layers, we can create a new layer, give it a name that represents the map we are creating, and then auto-generate the RGBA channels. Then making sure that we have the correct input layer, we can now shuffle our alpha into the red channel of our new hair layer, which we can then view in the viewer either by going through the drop-down menu or using the page up and page down keys to cycle through all of the available layers in the viewer. At this point, we now have the RGB, the mask, and the hair layers available. We repeat this again for the dress and the body of the dancer. Once we have all of the layers set up that we want to train on, we can use the layer contact sheet node, and while viewing the RGBA channels in the viewer, we can see all of the layers available at the same time. Because we don't need to train all of the black pixels of the background, and we want to make sure our training has only the information it needs and isn't going to take longer to train, we crop our frames around the dancer. We then need to copy this crop node and add it to our input frames as well. So like with our style transfer and mats, the plate frames are also focused on the dancer and now match what we have cropped for our ground truth input. If we didn't add the crop to this other pipe, the copycat wouldn't train, as we need to make sure that both the ground truth and the input to our copycat are the same. To help improve the training, we next need to create some identity frames to be used along with our dataset. Identity frames are useful and help to teach the network what it should not be doing by giving it an example of things it should not touch. So in this example, we don't want it touching the background elements, as we only want to affect the dancer. So we'll need to create some clean frames where we have removed the dancer. So for this, I'll be creating two frames, one at the beginning of the sequence and one closer to the end where we have more of the background elements visible. To do this, we create another branch in our tree, this time from those frames we had picked from the shot before our crop. And we create a frame hold on the frame that has the most background on it. Then because we have the alpha of the dancer now created, I can copy that into the alpha channel for the frame we had picked. And then using the InPaint node, we can quickly remove the dancer. Because the dancer is still now slightly visible, we can use an erode node to extend that alpha channel for the input of the InPaint until the dancer has been removed. Then, to bring some details back into the frame that were hidden behind the dancer, we need to create some patches from the other frames of the sequence. So we create another branch and pick a frame where the dancer has now moved past that area and create another frame hold, making sure we also have a frame hold on the alpha channel coming from the dancer and that it is set to that first frame we removed the dancer on. Once the dancer is removed, we then create a roto and a roto shape around that area we want to use. After the roto, we pre-multiply that and merge it over our clean plate we are currently working on. We then use a transform node to position the patch to the area where the dancer was, and then make any changes to the roto shape if needed. And then using other frames to create a few other patches for the other areas where the dancer was overlapping. To make sure we are only affecting the area of the dancer, we then use the alpha of the dancer we took to mask the merge, and then blur that alpha channel to smooth that transition between the patch and the plate. Once the dancer has been removed, to make sure the bounding box isn't going out of the resolution of the shot, we create a crop node which will remove that information outside of the format of the shot we are working on. Then to make sure that we are working on and focused on individual frames, we create a frame range node and set that frame range from 1 to 1. This is then repeated for a second identity frame. We now have two identity frames to add to our dataset. So we create a new append clip and plug the first input into the crop, and then plug our two new identity frames in as the second and third inputs. To train, both the input and ground truth need to have the same number of frames being used to train from. So we now need to create an identity frame for the ground truth. Because the dancer is on a black constant, to create the identity frames, we need to create two black constant frames, and then use another append clip to plug those into the crop of the dancer and its layers as the first input to that new append clip. The new black frames will need to have the same number of layers added to them, so we have the same number of channels for all inputs going into the ground truth of the copycat node, otherwise it won't train. To do this, we copy the shuffle nodes that we'll use to create our layers for the dancer and paste those under each of the constants. The last thing to do before creating a CopyCat node and training our dataset is that we need to then create a remove node after the append clip of our identity frames of the plate, and because we only need the RGB of these frames, we set the operation to keep and the channels to RGB. We do this because if we don't need particular channels when training, we can remove those. To double check that our frames are in the correct order, we could use a merge node and set it to difference and connect our two append clip nodes into that. So if you do have a frame mismatch, then it will be apparent. To learn more about how to set up a dataset, you can check out our Foundry Learn site, where we have tutorials on creating mats using the CopyCat and Nuke, as well as a CopyCat Quick Start series that will go into many more details for you. We then create a CopyCat node and plug in our ground truth and our input frames. And then in the CopyCat properties, for this setup on my machine, I set the batch size to 6, and then we set the data directory path to where we want our training data and CAT files to be saved. For a 1080p image, a crop size of 256 is really good. However, if for some reason you have a GPU limitation, you can drop this crop size to a lower value. But this would also mean that you would need to let it train longer to get the result you want, as it will see a smaller part of the image. So it is good to keep in mind that how you train a shot and the length of time it can take to train relies on your hardware and the GPUs you have access to. So once we have set up our CopyCat node, we click on Start Training. For more information on how to set up the CopyCat and its properties, check out our other Foundry Learn videos on the CopyCat node. While the CopyCat is training, we have a visual indication on how well the training is going through the contact sheet visible in the viewer. This is where you can see what the inputs look like and the outputs coming from the CopyCat. So as it trains, the results should improve and start matching the inputs we gave to the CopyCat. We then also have the graph tab on the CopyCat node itself, which is another indication on how the training is going. We want that graph to have a gradual downward trend, so if it starts spiking, that could be an indication of something not working in your training, in which case we could stop the training and check the latest CAT file it created, and then make any adjustments to the dataset before continuing the training. Once the training is complete, we then use the inference node to apply the result to the rest of the sequence. We set the model file location to the CAT file that has been created from our training, and on the inference node we can see the channels that are coming into it and the channels out. So for example, you can see that we have the RGB channels and then those extra channels we created through those layers. Viewing our result through the inference node, we can see that the CopyCat has done a really nice job. We also have a version of this training done for the shot where we didn't add the identity frames. So as you see, there is quite a difference in the results. The training where we didn't have those identity frames, we can see it has picked up the reflections in the window as the same as the skin on the dancer and tried to apply the effect to those as well. Where on the training where we have those two frames telling it what not to touch, the result is much cleaner and the effect is focused to the dancer. Looking back at our comp, we wrote out the result of the inference node as a multi-layered EXR, which when using the layer contact sheet node again, we can see all of those layers have been trained and the results are animated to follow the dancer. We now have the RGB channels as well as all of those mats available that we could use throughout the comp. For example, we could shuffle the hair layer to an alpha channel and use it along with a constant of any color to change a hair color to whatever we wanted. We could then merge that over our animated dancer to make this change. Or we could also replace the original dancer in the plate with our new animated version. So we could remove the dancer from the whole sequence of our plate with the use of the inpaint node again, and this time using our new animated alpha coming from our inference node's result. And then once the dancer is removed, we can merge our animated dancer into place while still having the control to make all of those changes to her hair, her body or her dress. So for example, you might also want to change the color of her dress. This was one example on how we could use the CopyCat to speed up and make more complex trainings inside of Nuke. Like how we did here with creating multiple mats at once, rather than repeating training similar tasks over and over again. We could also use the CopyCat to create different passes that weren't created for particular shots, like a motion or a depth pass. CopyCat opens Nuke up to a world of possibilities. Thanks for watching.